Welcome to another edition of Math for No Reason. In this edition, we are going to prove this result. Suppose alpha and beta are two transcendental numbers. You have to prove that at least one of alpha plus beta and alpha beta is transcendental. Let us begin by understanding what is meant by a transcendental number. The definition is rather simple. A number is transcendental if it is not algebraic. Now, what is an algebraic number? A number is said to be algebraic if it is a root of a polynomial with rational coefficient. Examples are root 2. Root 2 is a solution of x square minus 2 equal to 0. Cube root of 7. This is a solution of x cube minus 7 equal to 0. And there are many other numbers. Two famous numbers which are not algebraic are e and pi. These are not algebraic numbers. And since these are not algebraic numbers, e and pi are transcendental. Now the question says that if you have such numbers, any two such numbers, and there are a very large number of them, in fact, the transcendental numbers form an uncountable set. So there is a huge number of transcendental numbers, and if you take any two of them, then the sum alpha plus beta and the product alpha beta, one of them has to be transcendental. Both can be transcendental, but at least one of them has to be transcendental. Now, how do you show this? So, we will use the method of contradiction. So, the result that we will use for proving this fact is, so if a polynomial has coefficients which are all algebraic numbers, then the roots of this polynomial are also algebraic numbers. A property which is referred to as algebraically closed. Suppose alpha plus beta and alpha beta are both algebraic numbers. Then x minus alpha into x minus beta equal to 0 is a quadratic polynomial with roots alpha and beta, which means that x square minus alpha plus beta x plus alpha beta equal to 0 is a polynomial whose coefficients are all algebraic numbers. Now, by the above result, the roots of this polynomial has to be algebraic. So, this would imply that alpha and beta are both algebraic. But we know that alpha and beta are transcendental numbers. So, we have a contradiction. A number cannot be both algebraic and transcendental by definition. Hence, one of alpha plus beta and alpha beta has to be transcendental. That's a good point to stop.